and he'll talk to us about automated analysis of privacy requirements for mobile applications. Sebastian, take it away.
Thanks a lot, Manuel. So we are analyzing the automated, we are doing here an automated analysis of privacy policies. And to motivate our work, 2 weeks ago, Google actually asked developers to put a privacy policy on the promotion page of their app in order to describe the privacy practices they are using. And in fact, this is a requirement for all apps that are accessible to users in California. And what we do in this work here is we provide a system in order to analyze how many apps have a privacy policy. Secondly, whether the policy itself complies with the requirements of the law. And thirdly, whether the apps follow what is written in the privacy policy. And this is some work that is part of the Usable Privacy Policy Project. That's a multi-year, multi-institutional effort at Carnegie Mellon University in order to advance privacy technologies, particularly in the area of privacy policies. And what we need to do for our work is, on one side, we have the privacy policies, and on the other side, we have mobile apps. And we need to analyze these two domains. And for the privacy policies, we do that by using machine learning. And for mobile apps, in order to obtain scale, we use static code analysis. So let's take a look at how the machine learning side of things work. And essentially, we look for keywords first. And here in this example, we look for geo and GPS in order to identify location practices. And once we find keywords like these in sentences, we extract the sentences. And as a second aspect on the sentences that we extracted, we look whether these contain other keywords, which are called action keywords. In this case, for example, sharing. And once we find those, we extract from the sentences n-grams, particularly unigrams and bigrams. And these are then our features that are given to binary classifiers 1 for each practice that we want to analyze. For the apps, we analyze them using a three-pronged approach. First, we extract the permissions. So for example, if your app wants to use a user's location, fine-grained location, such as GPS, then the permission that is required is a fine-grained location permission. Secondly, we create a call graph for functions that we identified beforehand as being relevant for collecting location. So, for example, one function is called get last known location. And in the call ID analysis, we try to find out who is actually making the call. So there's a difference between an app making the call or a library making a call, because for an app, that means that is location collection, while for a library, it would mean that it's location sharing. So these are the techniques we are using. And what are we actually trying to find out? First, apps must have a privacy policy. Policies have to describe the data practices occurring in the apps. And very important, also must not omit that they are engaging in a certain practice. So obviously, your results change a lot depending on how you interpret the law. And finally, apps must follow the described practices in the policies. Our data set consists of about 18,000 apps, free apps from the Google Play Store that we crawled, and we downloaded the APKs as well as the metadata, such as the number of reviews that an app has, or whether an app has a policy link. These are mostly the popular apps, because we started our crawl from popular apps and then followed the links towards similar popular apps. The first result that I'm showing you here is that many apps actually don't seem to have a privacy policy. So 52% of the 18,000 apps that we analyzed have a privacy policy, indicated by the link on their app promotion page. But 48% don't have such link. And on the right side, you see now that about 12% don't need a privacy policy because they don't process personally identifiable information. 17% have a policy elsewhere. So these are app developers who decided not to post a privacy policy link on the promotion page, but rather have it only on their website, for example. But then we are left with 71% of apps that actually would need a privacy policy but don't have one. So that's 1/3 of these 18,000 apps that don't have a privacy policy. Now, if we look a little more into the policies themselves, whether they follow the privacy requirements, first of all, I want to show you the result for policies. So, for example, notice of policy changes means that an app developer needs to identify how it or he or she notifies users of policy changes. So, if I change my collection or sharing practices, I need to indicate that to users. I can send them an email, or I can make a note on my website that my policy has changed, and that's a requirement that we derived from California law. And as you can see here, 46% of apps don't have this kind of information, how they notify users. And to my knowledge, these are all apps that are available to Californians. I have not seen a single policy that says, our app is not available to people from California. The other practices that I want to discuss refer to the discrepancy between policy language and apps. And so, for example, the collection of identifiers, identifiers being device IDs, ad IDs, MAC addresses, happens in apps quite frequently, and 50% of apps don't disclose this practice in their privacy policy. Sharing of location information. So that's information, precise location information, but also approximate location information through Wi-Fi addresses, through IP addresses, for example. 17% don't seem to indicate in their policy that that's what they're doing in the app. Sharing of contact information is a practice that involves sharing of email, sharing of the phone numbers. These are the two items we looked at, and occurs in 2% of apps and is not revealed in the privacy policy. So overall, these numbers are relatively high. We did not expect that many discrepancies between policies and apps. And as you can see from our precision, recall, and F1 scores, we believe that these discrepancies are faithfully represented to a large extent, and that this type of analysis is actually able to detect the discrepancies. We tested that on 40 app privacy policy pairs. This is an overview that shows you for these 18,000 apps, the distribution, how many discrepancies we found. So most had at least one or two, and on average 1.83 instances of potential privacy requirements were there, and that's out of a total of 6. So we have collection and sharing of location, collection and sharing of contact, and a collection and sharing of identifiers. I want to emphasize that non-compliance does not necessarily mean that a law is violated, because it can be, for example, that an app is not intended for a particular audience and that a certain legal regime does not apply. Secondly, because we are using automated techniques here, there's always the possibility that there is a mistake in there. We verified our results, but we obviously did not go through all these 18,000 apps. In order to get a better grasp of what might be worthwhile investigating, what this graph shows you is that you can actually use the metadata that is available on the Play Store to predict populations of apps that might be particularly worthwhile looking at. And so, for example, developers sometimes receive a top developer badge, which is for creative ways and novel ways of creating apps on the Play Store. And apps that have such a badge are not as likely to have a discrepancy between policy and app as others that don't have this badge. And then the more users an app, user ratings an app actually has, this likelihood goes down further. So this is a logistic regression model that predicts the likelihood of having at least one potential non-compliance. So it's possible to use app metadata to predict which app populations have increased potential of privacy requirement non-compliance. So our work is intended to help developers, app store owners, and regulators. We believe that most app developers are not malicious. So it's often that they're amateurs or that they're small developers and they don't actually know what the requirements are. They are complex. And so one way of moving this forward is to integrate our technology in software development environments, generating policies, analyzing code from there. App store owners can also help vetting apps, once the APK is uploaded to the Google Play Store, for example. And regulators are a third category who can help out here. So they have the problem that they don't have many resources. So this automatic process that we introduced here can help them to get a first grasp of where problems might be and then look more detailed into them. And in fact, we piloted the system with the Office of the California Attorney General, and we are continuing to refine it and improve it as we go along. There are further possible ideas extending this towards the emerging Internet of Things domain, particularly as privacy policies might be different there. Maybe they are machine readable, maybe there are no screens. And so what you can imagine is, for example, to measure the discrepancy between a policy and what's happening, and then notify the user of that discrepancy, for example. Thank you very much for your attention, and I'm happy to take any questions.